All right, so let's have a look. Okay, quick review of our thinking. So we looked at, if we looked at this example, right? Let's click them all the way close, please. I want everybody's undivided attention up here, please. So we said that this was an easy one to do. We know that the absolute value of x equals 8 when either x equals 8 or x equals negative 8, right? So quick, I'm going to add one more problem for you, just to convince me that we're good to go here. So what if I had something like the absolute value of 2x plus 1, make it a negative 2x plus 1, equals 9. Okay, what's my approach to this?
You split it into negative.
Okay, good. So we know once we isolate an absolute value, think what we're doing. If we've isolated the absolute value, then whatever number we end up getting inside the absolute values, we only have two choices, right? That expression inside the absolute values either has to give us a 9, which works because the absolute value of 9 is 9, or it has to give us a negative 9 because the absolute value of negative 9 is also 9, right? So when we get it to this point where we've isolated the absolute value, then here's how we make that substitution. Remember, we're always going to say, well, whatever the expression is inside, negative 2x plus 1, it either has to equal 9 or it equals negative 9, and we just solve those two equations. Because our rule is, you might recall from yesterday, our rule is that we never can touch anything inside the absolute values. Right? We have to isolate the absolute value and then undo it by making the trade for those two simple equations. But we can never do any algebra inside the absolute value. Now, I guess I'm not going to say never, but very seldom. And at this point in the class, assume never. Okay? All right, so what would the steps be? Let's just walk through this one really quick. Okay, good. So we're going to subtract 11 on both sides. I get 2 times the absolute value of something, we don't care, is equal to 68 divided by 2. So if I divide by 2, then I get the absolute value of some stuff equals 34. So now finally we can look at what's the stuff, 2x minus 20. Okay, so what has to be true? Okay, so 2x minus 20 either has to equal 34 or 2x minus 20 has to equal negative 34. Okay? So what if I had, like, let's go back to that previous example for just, how about this one? Could I turn that into a positive 2 and a positive 6 because it's inside the absolute value bars? Does that sound wrong? Because it is. Can't do that, can I? Can't do anything inside the absolute value bars. If I did that, that's going to change the values of x that make this whole thing true, right? So resist that temptation. That's something, if you're in a weak moment, everybody wants to do that kind of thing. They want to apply the absolute values and turn the stuff inside positive. Can't do that. So we've got variables in there. That's going to change the values of the variables that work, right? Okay, so let's keep moving forward then. What about this one? What would I have to do to isolate the absolute values there? Yeah, good. Multiply both sides by 3, and then I'm good. Then I can make my trade. Okay? How about this one? Add 11. Okay, let's do this one. So if I add 11 to both sides, I get 2 times the absolute value of some stuff equals 0. Okay, I got to isolate the absolute value. So what do I do next? Divide by 2. 0 divided by anything other than 0 is 0. So I get the absolute value of some stuff equals 0. The stuff is 3x plus 6. Well, how do we interpret that? I get a number out here that this time I don't get a positive number. I got 0. So if we tried to apply the old rules we've been using, we would say that either 3x plus 6 equals positive 0 or 3x plus 6 equals negative 0. That's kind of nonsense, right? Is 0 positive or negative? Equals 0, doesn't it? 0 is not positive or negative, it's the boundary between the two, right? Two parts of the real line. So we get one simple solution this time. 3x plus 6 equals 0, so I can subtract 6, divide by 3, and get x equals negative 2. Right? We could plug that in just to check it. 2 times 3 is, or what's our answer, 2? Negative 2. 3 times negative 2 is negative 6 plus 6, 0, absolute value of 0. 0, 2 times 0 is 0. So negative 11 equals negative 11, check, it works. Gives us it satisfies the original equation, makes it true, right? Okay, questions? Okay. How about this one? Add 1, okay? Good, add 1 and divide by 3, so we're going to get 3 times the absolute value equals, if I add 1 to both sides, I get negative 6. Divide by 3, you said, right? So that isolates the absolute values, and the absolute value is equal to, okay? And inside the absolute value is 2x minus 1. Okay? Anybody tell me what the answer is?
No solutions.
No solutions. How come?
Times can't be negative.
Ah, okay, good. Good. So right away, we can see there's something fishy going on here, right? And we could do more work, but it's going to be a waste of time. If I have the output of an absolute value is equal to a negative, is there any value of x that's ever going to make that true? No. You could never do it, right? There's no number of any kind that I could plug in for x. And when I evaluate this expression, I'm going to end up taking the absolute value of something, right? The absolute value of something is non-negative. It could be 0, but it can't be negative. It's either positive or 0. So we know right away that that's no solution. If we did the math, how would you even do the math? It'd be a little bit awkward. I guess we could do something like 2x minus 1 equals negative 2, or 2x minus 1 equals positive 2, right? Maybe that's either the negative 2 or its opposite. If I do that math, though, if I add 1 and divide by 2, what am I going to get? Negative 1/2. Okay. Negative 1/2 is one solution, potentially. How about this one? If I add 1 and divide by 2. Okay, I heard it. 3/2. Let's try those. Negative 1/2. If I plug negative 1/2 in, I'm going to get 3 times the absolute value. What's 2 times negative 1/2? Negative 1 minus 1. Negative 2. Is that equal to negative 7? No, I'm going to get 6 minus 1. That's not equal to negative 7, right? So we know that this is, what kind of solution is that if it's a false one? What do we call that in math? You're right. I mean, we're going to get no solution, but this solution right here, it's false. What's our fancy math word for false? Extraneous. Have you never heard that before?
We've never heard that.
Seriously?
No.
Okay. All right.
We were like,
Okay. So there you go. Now you've heard it. Okay. So it's an extraneous solution. Okay. It doesn't work, right? And if we try 3/2, we're going to get the same thing. I promise you, we're going to get the same thing. In fact, it's going to look just like this. If I try 3/2, I'm going to get 3 times 2 times 3/2 is 3. 3 minus 1 is 2. So I'm going to get 3 times the absolute value of 2 minus 1 equals negative 7, which is also not true, right? So the math gods, they do a good job of making sure that things work out the way they're supposed to.
Except when
And
they
so,
don't.
of course, this one didn't work, but we knew that right away. Grayson saw that. We had a negative sign there, and that meant it wasn't gonna work ever,
Good
right?
job, Grayson.
Okay? Okay, what about something like this? So this is a little different look, right? The same approach, but now we've got variables on both sides. But we can apply the same thinking that we've been doing to this situation also, right? There's nothing special about a variable. A variable represents a value of a number. So the same stuff we were doing before is going to work here. What would we do? Divide by 3, okay? So if we divide both sides by 3, that's going to cancel that 3, and I end up with the absolute value of 10x minus 7 equals, what am I going to get on the right side if I divide by 3?
13x plus 5.
We'd split that into separate fractions, and each of those separate fractions would reduce, right? So then what's that tell us? If we're trying to solve this so that the absolute value of 10x minus 7 equals 13x plus 5, what are the two things that the blue expression could equal? Now, this is a tougher one to think about. But in order for this to work, and you got to keep in mind that eventually we're going to get solutions for x that we're going to plug into this thing, right? So we're going to plug in x values, but when all is said and done, I'm going to plug in some x value in here, and 10x minus 7 is going to give me back a number. When I evaluate that expression for my solution, I'm going to get a number, right? When I evaluate 13x plus 5, I'm going to get a number. What would have to be true there? The blue number would have to either equal what or what? That number, right? Or its opposite. Everybody agree? Okay, but we don't know what the number is yet, right? We're gonna get numbers that are gonna work potentially for this, right? We're gonna check them. But whatever they're going to be, when I plug them in, 10x minus 7 is going to have to either equal what I get from 13x plus 5 or negative the quantity 13x plus 5. Agreed? Okay, so how do we find the numbers? We solve those equations. What has to be true here is that either whatever's inside 10x minus 7 either must equal 13x plus 5, or, remember that's our symbol for or, 10x minus 7 has to equal negative the quantity 13x plus 5, because the absolute value would make it positive, right? So I can just solve those two equations and see what happens. So over here, this is a pretty easy one. Where am I going to push the x's? To the right. Good. So we're going to subtract 10x from both sides. Cancels the 10x's from the left. If I'm pushing the variables to the right, let's kill two birds with one stone here. Where do I want to push the numbers? To the left. So the 5's go away there. I'm going to end up with a negative 12 equals negative 13x, or 13x minus 10x is what? So one possible solution is x equals what? Okay? How about over here? Probably distribute, right? So I'm going to get 10x minus 7 equals negative 13x minus 5. Okay? Where do I push the x's? To the left. So I'm going to get x is left, which means I want to push numbers right. So I get 23x equals 2. So then if I divide both sides by 23, what do I get? 2/23. Okay, but now when we've got variables on both sides, we've really got to check our answer, because it's highly likely that at least one of those is going to be extraneous. So let's check. gonna show you a little trick for checking. So you can use it, I mean, you could just power through with the fractions, but here's a way you can do this with a calculator. I'm just gonna pull up the Desmos non-graphing calculator.
How do you spell extraneous? I don't think
Okay, so the -4, all you ever have to do if you want to check this stuff, remember, is we're just going to evaluate the left side of the equation and the right side of the equation and see if we get the same thing, right? So we could do our original equation, that was a 3, right? So we get 3 times the quantity, 10 times, and then what I would recommend doing is every place where you're going to insert a variable, just open up a set of parentheses. So you can plug in the number. So we're going to get a 4, -4, whoops, -4, -7, and those are all, oops, and we need absolute values. So what I really need to do with that, let me get rid of it. I got to pull up the absolute value function. So I go to function, in this case, on your calculator it might be a little different, but this is just a basic scientific calculator. And if I go function, there's my absolute value. So I get the absolute value of all that stuff. And it gives me an answer of 141. Okay? Let's try the right side. So on the right side we had 39 times, plug a 4 in for our x, plus 15, and we get 171. What's that tell us?
Nope.
Oops, that was supposed to be -4 though, wasn't it? There we go. Still doesn't work. I get 141 on one side and -141 on the other side. So what does that tell you about x equals -4? Not true. It's an extraneous solution. Okay, so there's one we can destroy. There's one we can get rid of. He's done. Whoops. He's done. Let's try 2/23. And here's where the calculator, where this gets pretty handy, because those fractions are sort of a mess to deal with. So let's go back. Now what's nice about this, and you'll have, what I'll start doing, I can't remember if I've done it yet or not, I keep forgetting to do it, but on the assignments, typically I'm going to embed the Desmos non-graphing calculator so you can use it within the assignment. It'll be there for every problem you do. So you can always pull it up in a separate tab and if you need it. So let's replace the -4 with the 2/23. So I just do 2 divided by 23. And over here I'm going to do,
a lot of numbers.
yeah, 2 divided by 23. What do you notice this time? They are the same, right? And if I make them exact answers, if I hit the fraction, convert to fractions, and it only offers you that option if it does convert to a fraction, which these do, we get 423/23 in both cases. That's what both the left and the right sides of the equation would give us, but clearly they're equal. And so we do get one legitimate solution here, and that's this guy. That one checks
So
out.
that would just be the.
So we get one solution in this case. One would be extraneous, you'd only enter one. It's possible that sometimes they might both work. Okay, but one of them didn't this time. Okay, make sense? All right, what I'm probably gonna do you guys even, I mean, I don't even know if we need to go through stuff like this. I almost don't think I wanna waste your time talking about it. But what if I pulled up,
Grayson, you should drop something.
I'll hold off till tomorrow. We'll do that tomorrow.